Good morning, everybody, and welcome to our second session of building systems. Still about 52 people are logged, so we are missing about 6 or 7 people. Okay, subtitles I forgot. I think the subtitles are now working. Thank you for reminding. So today we have an introductory lecture. I put a note, but it disappeared now. Please log in Blackboard because we will make a couple of activities there. Today, while people keep coming in, why? Okay. Welcome, latecomers. So today we are going to speak about what we have to define the subject and the field we are treating, and then, as we commented, we'll speak about architect and engineer, which is a difficult but important relation we have. Let's go on. What is a system? If you go to Google, one of the first hits is the solar system. And this is quite interesting because it illustrates very well what a system is. I think we are all familiar with the solar system. We have a series of elements which are clearly distinct. Yeah, we can separate, we have planets, we have the stars, we have the satellites, we have the asteroids, right? So elements are clear. And we know that they need to be together. It's complex. So they have all their own place, their position. If you remove one of them, the whole system will have a big problem. We'll have to reorganize. So all pieces are perfectly fit and necessary for the balance for the system to work. And that's a good definition of a system. If we go to the textbook, some of you had materials last semester, so it will be very fresh still. Remember that the book of the Blazes we recommended as a basic bibliography went into several stages of construction, starting from the raw material, then going to the modules, which are the basic parts we made from those raw materials, which we can really use to do something. Then the elements, which is an assembly of those elements. Then we go to have some people coming late either. Okay, so we have those elements we said. And then what the book calls structures. Please be quiet. Yeah. You're late and noisy. That's the worst combination we can have. So this is one of the translation problems. Structure is what we translate as architectural systems, which is the subject of our course. And as an example, we said, well, interior partition system, which is also a subsystem of the interior, but partitions have combined those elements and create a clear set, right, within the building, right, as we defined the system before. Then we have, again, we have a plan of translation, right? The structure, which is the whole building, which is a set of systems and subsystems. Right, and that's the finished building, also with timber. So I think in this context, we have clear what is a system within the context of the whole construction process. If we have to ask, right, which are the basic building systems we have? Well, you know, the syllabus is based on that, but still we have to distinguish them. The first one, right, will go after the survey. So this is where you go to Blackboard, and in the assignments and tests section, you have one survey open. You will have 5 minutes to complete it after the password is announced, which is announced now, right? So Aina is everywhere, coming late, and we have Aina, please put your student number and your name I know you're everywhere, but it is not nice to be everywhere late. We have a survey, which is interesting. I think 5 minutes is enough to complete it. And it will be used also for your attendance. So those who arrived in the first 5 minutes, probably in the first 5-6 minutes, will have record of being on time in class today. So I see nobody taking, maybe there's a problem there. Okay, let me check again. I will check. Maybe my mistake. Let's see. That's a good way to test if you're really in class. Okay, please look in the chat. That means I will have to give you. I put the correct password. Yes, there was a mistaken letter. Sorry, that's my transcription mistake. I should have copied and pasted. So to have it correct, this is a small k, right? Small k. Those who cannot open the survey because they use the app, maybe you could try to go online, from the Navigator. And Jongwoo, you're late, but you're lucky because you still can take the survey for attendance. So it does not work. Use the browser, right? This is why it is good to use some solid equipment, either a tablet, or tablet is the same problem, but it's easier to manage, or computer. Okay, 2 people already finished. Okay, we are 10 minutes into the class, so nobody can take it anymore, but you can finish if you started. Somebody knocking the door. Almost everybody finished. A few still working in. And Soyeon just came. Suyeon. Hello, Soyeon. Good morning. Kitty, you arrived more than 10 minutes late. You could not take the survey. And you will appear as late today. Well, let's see if everybody finishes so we can continue with the class. Okay, 3 people still working. One person, we're almost done. Okay, we are done. Survey done. So if you had materials or you're retaking building systems, you should be mainly coming now. Mainly, sorry you're late. Welcome to the class. You missed the lovely survey. I was going to say, if you had either building systems last semester retaking now or materials, you will be used to the system. But I want you to become familiar with it, if this is new for you, to see if this works, because now we have another survey at the end. So please keep logged and keep attentive till the end. So we will take more decisions for the following sessions. I will let you know the results on Thursday next week. One more comment, as I said, I visited yesterday the classroom. It is a lovely, nice classroom in the second floor of Innovation Building. I counted 85 seats, which is quite appropriate. So we will have, as I said, a final survey related to this classroom, okay? Which I think, yeah, we used for material class like 2 years ago, and it's a nice class, right? So that will come later. Let's go into our systems, back to the Soyeon late to class. No, we have Soyeon and we have Suyeon, right? There was a message in the chat. And you know, my Korean pronunciation is quite bad. So maybe I think I say one name and I'm saying other one, but the one who was addressed knows very well. Whatever. Again, those who came late, especially, yeah, just in case, remember Suyeon mainly, and right, put your student name before, student number before the name, so it is easier to follow your logged in as a habit. So the first system we have is the site. And I mentioned this because we don't have a site-specific lecture. We will comment about it in structures, right? But a site is actually half the project. If you're fifth year, you should be familiar on how important is the site for the project itself. But well, I shouldn't insist on that, right? Not only for design purposes, but even for technical purposes, right? We will comment on that later, but site is an important part. As we said, in structures, this is taken from the structural systems. We have one building, and we are very worried of the structure supporting all the weight, but nothing works if the ground is not able to turn that strength back, right? This is basic Newton's physics. So if the building is twice as big, the ground has to be twice as strong. This is as easy as that. And as simple, as basic, and obvious as it is, many structural disasters come from ignoring this point. We have also the landscape, right? Landscape is part of that. And in this kind of very specialized trend, or this trend to specialize the majors, we lose often the track of the globality of things. Architecture is everything, including the landscape surrounding part. You might have a specialized people doing it better than you, but should be part of the project. Otherwise, it happens as it's here. I used this slide because it's the one I had chosen. I could change it. I have nothing against Daejeon. It's a lovely city. But, you know, this building, which obviously seems to have had a big effort on design to show a kind of high technology station for KTX railways with less or more success, that's not the point. But you see, if you don't include the landscape in that plan, in that project, in that concept, chances are that you end having just a concrete or asphalt plate without much interest, and really in strong contradiction, right, with a kind of a expensive, flashy station. So landscape, something I would encourage you to consider part of your project always. And again, this is not a system we will treat. We have an optional course on landscape design, but even without taking the optional course, site is part of the project, whatever. And this is an example. This is a Sungshil University. Another example, I could have thousands, right? To have nice examples in which one problem, which is the difficult topography, is turned into one advantage. Instead of that trend to totally flatten the mountains we have often in places, as is the trend in Korea, just assume the topography and use it as part of the project itself. The second most obvious is structure, right? This is a structure in Yoito, a building which was abandoned for some long time. I don't know what happened to it. And you see the still getting rotten because of being over too much time, just abandoned. Whatever, structure is obvious, easy to understand, so we don't explain much. Buildings need the structure in order to stand up. But the structure has much more. It defines the spans, the dimensions, the scale, the character of the building to some extent, right? So it is not totally appropriate to think structure as something which is added after. This is integral, essential part of the building itself. Well, we have a DTP. This is a historical photo. If you didn't sit in construction, it is nice, really interesting to see what happens inside that element. We will comment into that later, but it's about those crazy structures we say sometimes. I would say this is not especially beautiful structure, but we'll comment into that. And this is a photo taken just very recently, a couple of months ago in Madrid. It is two towers for the 1970s, which are getting a new expansion on height, which is quite risky, but it's still possible. So they will add maybe 10, 20 floors to make it higher and more modern. So structure, as we said, we have lectures on the basics and the structural elements, and see, we start with the ground as the basic element. Then we will go fast because this is basics, but we need to review, right? From the materials and elasticity to the loads, the ground, and then vertical and horizontal elements. It is quite a traditional way of dealing with it. And I'm kicked out, so I have to, again, go to the shared screen. This is a network. Let me go out and share again. Let's see if it works, because it doesn't always work. Well, it is starting, but it doesn't work. Let's make a second try. Stop and start again. Let's see if it works. Okay, it works now. This is one of the pains of the online sessions. Sometimes the system doesn't work. So we'll have 2 more lectures, maybe more interesting, which is how we integrate them. And it's only 2 lectures, but we do what we can, how we plan, how we can, or what do we have to take into account regarding design calculations and rough numbers. Sustainability, of course, as we said, is important. And if we have time, just to show the construction process, it's just a photo album of works, so you can see the reality of the construction of one structure. Next system is envelope, right? And this is where we will spend most of our time. As we said, this is the first and most important layer which creates the interior space, and that regulates how light, air, and sound comes in, right? This photo is taken from a project from Obra. Obra is one office here in Korea, I think Seoul and New York. And it was in the one of the pavilions they used to do in the Seoul or Museum of Modern and Contemporary Art of Seoul. I don't know how they call it, of Seoul, next to Gyeongbokgung. Quite interesting experiment on how you can make a prefabricated temporary wall with weird windows. We are more used to have the curtain walls. This is from the Hyatt Hotel in Yeouido, quite elegant building, very classical solution and very common, and we will devote some time to them. We have the other vision, which is the heavy walls. This is a building in Madrid, already about 80 or near 90 years old. Heavy construction, but still good quality and making a good or suitable interior environment. And I'm out again. What happens today? We will never end in this way. Let me try again with share the screen. Yeah, unexpectedly, the screen sharing was stopped. Okay. It works. Let's continue before it breaks down again. So we will have some lectures on the basics. I will try to repeat as less as possible, so we go over what we saw in materials. Let's see what happens, because I have to remake and update things. And then we will go spend some time in the most complicated elements, windows and curtain walls. So this is basically what we saw in materials course in second year, but going up one level in depth and complexity. Hopefully it help the understanding. These are some of the examples we see, right? New buildings or modern buildings using traditional techniques and so on. So we will try to see as many alternatives in envelope design as we can. And then we will spend some time in roofs, right? Flat roofs and sloped roofs. It appears as though, so don't ignore the numbers, because this is not the numbers, right? Because this is from last year lecture, I didn't update everything. And instead of expanding theory, what we did is to keep it in one lecture each, and instead do more case studies. Case studies we did as much. Actually, this we did also last semester in materials, but there are endless possibilities, so we'll try to go into it. Next is interior systems, right? And obviously we have one optional course, quite nice in the school, mostly design oriented. Now we will have just a few lectures more technically oriented. So you have the tools to make those designs possible, or at least to know the possibilities and the limitations of that interior design you're planning. So we will have the basic construction, partitions, finishes, furniture, finishes including suspended ceilings and things like that. Health and materials, this is a repetition from materials class, but we have to give a mention to it, it's a requirement. And then new from this course is the whole process of dealing with the environment this is passive, right? So natural light, natural ventilation, passive acoustics mostly. You see this is not lecture 9, again, ignore the numbers, just the contents. And these examples of those partitions and partition elements we will see, right? How you make a detail of a door or furniture, and which are the things you have to be careful about. Hopefully it will be helpful also in your process and understanding on the construction. This is also taken from one lecture we will see later, how we deal with the natural light, which is not so difficult, but it has much more complexity and many more things to deal than we do usually. Next one is MEP, mechanical, electrical, plumbing systems, and in general, active systems, right? Or active environmental systems and services. We can complicate the title, but this is what we call all kinds of installations, machinery, and additions we need to put in the building for it to work. And active means they need some kind of energy, some kind of a device, which is not just the basic elements we do for the envelope or the interior. You can say water apparently doesn't use energy, but you will have pumps and things that really, you will need some kind of machinery, right? And some kind of engineer dealing with it. So this is the systems part. We have, again, 2 or 3 courses about environmental systems, very well organized. In this case, we will not try to see everything, just to see what is important in terms of your project. Conveyance, which is elevators, escalators, moving elements, right? We will see also briefly. And fire protection systems are not explicitly or specifically included in our course, but they are obviously part of those systems, right? Those service systems. And we'll see it briefly also. This is again, forget the numbers, but more or less what we can see. What is the needs, how we deal with the environment, and then which kind of elements we can add to improve this interior environment, not only seeing and hearing, but also living, right, which is more obvious. But sometimes we forget we have to navigate through the space, and we also forget that sound is an important part of our project. And as we said yesterday, many people criticize architects must be deaf, because deaf also, I'm reading the subtitles, deaf, right, cannot hear, because acoustics are totally ignored. These are examples of tips and considerations you may have, just to have the basics, and then you will understand what other engineers are doing, or you can do it yourself if the design is not too complex. Sometimes the engineers and the so-called experts will charge you a lot for things that you can do yourself perfectly on your own and with much more control. And this is another example of things we do, which is going into real existing technical information and checking which elements we have to look around, right? And understand what are all those elements. So this is like a really, really realistic office work and design work. Going to the last element in which you choose the elements and have an idea of the effect they will have in that space you are creating or designing. Heating, ventilation, air conditioned systems will have some time. I'm not specialized on that, but again, knowing the basics will help you deal with it, right? And know what is what. I insist a lot of the heat exchanger because still many of you in the assignments use like old-fashioned systems we don't use anymore. I try to use the best in terms of health, interior health, but what we will do in the proper time. And of course, the famous SPC12, the protection, of which we cannot deal much because we are limited, but we have to insist on that. And I will try to give you the basics, most important basics, from which you can just elaborate and understand better the detail of the codes. The codes for fire are quite extensive and complex and full of requirements. But if you understand the basics, it is very easy to follow and to know in which points you have to be more careful, in which you will need to go beyond the code, because codes are minimums, and in which part of the code is like really more than enough. We'll do that maybe in half a lecture. We will have quite a few lectures on sustainability and system integration, and this is something we will say, okay, we will speak of, this is taken from the lecture, right? So we have different systems and different specialists, and this is where system integration come into play. We will see it later. And so we have an idea of the systems we deal with. Those systems have subsystems, as we said, those active environmental and protection systems. There's plenty of subsystems inside. We will see them as a block. And the last slide we just saw before, this one, right, just explains you the complexity of those building systems, but we will deal with that later. And I did a mistake that we have to repeat everything I did before. Okay, so let's go to more rewarding part, the relation between architects and engineers. I put on the cover two of the most amazing collaborations between architects and engineers in the 20th century. This is a Gio Ponti, Italian architect from Milano, and this is a Per Luigi Nervi, one of the best engineers ever in the 20th century. And those two persons working together did some of the best buildings ever. So let's start from the beginning. And I will start, I could go earlier, but let's go to the traditional architecture, the Gothic, which is one of the peaks of the stone construction technology. This was a technology developed over centuries, but in those cases, there was not clearly engineers or architects. There were artisans, and actually you have the name of the builders of those cathedrals, the ones who started the planning. You need to have some organization, but it's very much an exercise of the whole collectivity. This is Leon in Spain. We're speaking of a 12th, 13th century, or 13th, 14th century, let's say. This is a huge building even now. Probably at the time this building was built, that town might have 10, 20,000 people, which means a huge commitment, not of the population, but several generations to make this building as the pride, the symbol, you can call whatever you want, right? But this is not the division between people who make and people who use. Everything's much more softly interconnected, right? It's not that stiff division we have now. I think it's easy to understand, or not. Well, what I mean, in that moment, all the rules in the construction were quite collaborative and quite diffused, right? Even though we had the guy who knew very well and make the basic planning, and the stone makers, and the carpenters, and the glass makers, and all the community working and supporting to make this building happen, right? Those roles were not so much divided. It was very much a work of everybody. This is another case, Astorga Cathedral in that area. This is already 15th century, but again, they produced spaces that even now, if we think of making those buildings, might be we couldn't do, because there would not be that commitment, that support, that energy to make this, right? And they work perfectly. They have the perfect interior environment, the perfect temperature. It is a bit cold in winter, but still you can stay the 1-2 hours of celebrations, cool enough in summer without the need of additional support. You have the proper amount of light because you use it at the daytime. It has the perfect acoustics, and this is something they did very well. The acoustics of the churches are perfect for the kind of celebrations and the kind of music and colors they had at that moment without need of that electronic correction. And it worked for hundreds and hundreds of years. This is another example. This is the Cathedral of Edinburgh, right? It has been like 300, almost 400 years in the making, right? And you can see also, it's interesting to see how those generations change the styles, but also coordinate new and old. And you have interesting things like new spans that do not fit the old ones, and you have to make a solution which is kind of scary, but it's done quite intelligently and provide some kind of points, if you are a trained architect, that are quite interesting points, right? They create attention there, which seems to be intentioned. This image from the 15th century, this is imagination, right? The construction of the Solomon Temple, but actually it's like the construction of one Gothic Cathedral style. But you can see how the building is huge, it's enormous, it's great, it's going to heaven. Solomon Temple is like the symbol of the architecture for God, right? The top people put in that century. But see how the whole artisans are mixed with the people. People can see what's happening around. This reminds me the quote by Louis Kahn, right? You know, the famous American architect, right? Who said, one city is a place where a child just walking around the streets can see and decide what he will be when he is old. And I think this gives that kind of sense, right? You can see the carpenters, the stone makers, the people supporting, giving food, and thanks to the artisans, the ones taking control, right? So it is very easy to see how things work. The involvement of the whole community is enormous. But then we go to the Renaissance, and probably I could go to Brunelleschi, but I have the image of Michelangelo. We are already 16th century, and I will not go into the very small nuances of history, but this is recognized as one of the first buildings in which the name of the architect, in this case, the sculpture, Michelangelo, is tied to the design, right? We have one person, which is only one person responsible for the object. And it is amazing to see that one sculpture had enough knowledge of classical architecture, of construction, of materials, of physics, to make one dome, which stands today, and which could be scary to make with that technology, with those materials today. Of course, it needed many repairs and many additions, so it's not as easy as say it worked perfectly, but still, it is amazing. So in this moment, we have starting the dichotomy or the division between designer, which is a word I hate, the architect, right? Well, we can comment later on why, but this is kind of personal preference. Designer is a bit standard now, but architect. And the builder, right? The people who make. So the person who plans, who makes the project, and the people who build. And this is happening like 500 years ago, more or less. As you can see, you have each of the plans have a name, right? And they all worked with the previous scheme to update. You can overimpose to have the final result of the building, right? Well, this is not much about, but it is about systems. It's about how one structural decision, because the first one started the construction and the foundations were made, then the columns were made. So the following architects had to update that design, but with that structural constraints, which were based on decisions on the size of the dome, about 30 meters, which is a huge dome, right? and the general church of the general spans of the church. So decision of the spans related to the possibilities of the technology we have, domes and vaults, and the materials, stone, are vital in one design, right? And I wish you embody that in your mind. Dimensions are part of architecture. You cannot design in abstract and then see how you can solve things structurally. Well, of course you can, but always there will be kind of a detachment or kind of inconsistency between design and the structural solution in general. Well, we have the model, they made models also, and the drawings are absolutely beautiful. It's not the question that they are beautiful. I think we should aim to make to embed in beauty everything we do, right? But mostly buildings, which is our work. This is obviously a design section where you show the space and the outside and not so much the details of the interior. So design section usually deals with interior space with much detail and probably the exterior finishes, but not what happens in the interior, which would be a construction section, right? In a construction section, we will just give the detail on how those things are made. This is correct. It tells you the proper thickness and gives you a hint on what happens in that thickness, right? Again, that thickness, we spoke of spans. The thickness is other of the things that should be aware from the beginning when you design. Maybe you don't need to calculate things, but you have to know for those dimensions of the span, those spans you considered before, which kind of thickness elements will have when you section them. I see often projects, even in 5th year, and even in professionals working with engineers, in which thickness are totally unrealistic. And that does not provide the feeling of the building as it is. And if you don't have the feeling in the drawings, how can you control the final result? In this case, you have the feeling of a huge building with relatively light construction, but it's obviously stone construction. If we do this with the steel and glass, the feeling of the whole building will be different, right? So thickness, spans, keywords, great with Michelangelo. And this is great. We have in the archives so many sketches, right, of Michelangelo giving instructions to the masons to create the elements, right, and the design of each small detail of the building. This is not of the dome. I think this is the Medici mausoleum or tombs with the Mose, the Mose sculpture. And there's one more thing which is interesting here. I think I'm going a bit away from the subject of engineers and architects, but this is telling you how sophisticated that technique is. This is the old St. Peter's Basilica church, which was a large church. So making a new construction by keeping the old one alive is something we do today. And usually engineers and architects brag of the technical difficulty of doing those things. People were doing that in the Renaissance already. That means how sophisticated, how confident were those architects, let's say, Bramante, Raphael, Michelangelo. And this was one of the, also probably the factors which brought the decision of those spans definition, right? Of course, being sure that the vaults will be able to support that span. Let's go to the modern period. This is already 19th century. Okay, this is 200 years ago almost. This is Scotland, this is Edinburgh. Playfair is one of the best architects of Scotland in that period. He was, well, Scottish did a lot of research on classical architecture, not Roman architecture as we got from the Italian classicism, but on Greek, like going to the origins. And this is the Royal Institution. I think now is the National Museum of Scotland. And you see there's already a small division, there's more specialization. There is a question of safety and access to the quarry, but yet you can see people working on the street, you can see people supplying food, you can see people looking around and hanging. So you have still some kind of a connection, right? Even though the specialization is much stronger and there's some kind of a safety and division between construction and society, the role of the architect, the builders, and the citizens becomes a little bit more separated. And then we go to today. I chose this image because it's fun. These are a couple of architects, couple professionally. I don't know their private life. James Cowan and James Sterling. In words of some people, James Sterling was one of the most interesting and most able architects of the 20th century. Those two were working together for quite a long time. They had different ways. And curiously, they have a very good balance because James Cowan was like the Gothic guy. And it's just a coincidence, he was slim and Gothic is slim, but he was very much worried about how to build the buildings, right? He was very aware of the need to have design and the structure all in the same concept. James Sterling was much more of the Renaissance guy. And curiously, he was a fat guy, really fat. This may be one reason he died relatively young, which is a pity, because we lost one big talent. Talent is quite scarce. And physically, they are quite similar. But James Sterling was much more a guy with a sense of the shape, of the space, of mass. And he thought that structure planning in the way Gowan was always obsessed was kind of hindering, and he would plan structure in the end. So this is why I said in general, structure should be part of the design. But we have some genius, you have to be really talented to do that, who had a secondary consideration of the structure. But don't misunderstand, he knew very well all the basics of the structures. And there's not totally ignorance of the structure during his designs. Just to give one more example, this is in the collaboration of Sterling and Gowan, and this is Sterling and second partner, Michael Wilford. You can see the character changes totally, right? The fat guy, massive construction, and more classical, and the more Gothic guy, more constructive, more slim, light construction. This is how much those considerations affect the result of the architecture, right? To have one of the final examples, I think this is, we are going to the end of the 19th century. We are close to our time. And I think you are all familiar with Eiffel. Eiffel or Eiffel, how you want to call it, the famous engineer. Actually, we have only the name, but it was a huge office with engineers, architects, and a lot of people. And one of his best engineers, I don't know how this, maybe Görlin engineer, developed in 1884 a concept for a tower of 300 meters. You can see the idea of the Eiffel Tower, is no need to repeat, right? The shape designed for stability against wind loads, quite slim, with a comparison in height with Notre Dame, Liberty, probably some obelisk, Arc de Triomphe, and so just explaining to give the scale on how big things are. You see all these annotations with dimensions. I cannot insist enough. Even at the beginning, you need to be aware of the dimensions, the scale of things. And I think this engineer did very well. But you can see with his pencil, trying to make a classical pediment, because he sees this building is too mechanical, lacks the attractive architects can do. And of course, not having a training of architecture, this was not a good idea, right? He could have built this building, but nowadays it would look like one of those high voltage towers, right? Kind of more mechanical, not really architectural element. And this is where the collaboration with the architects. He had Nougier and Sauvestre, quite prestigious architects on the period, which were open enough to accept its new construction. And they devised some design, some decorational elements, which are much more fit to the material and to the system of the tower itself. So in this case, engineer and architect collaboration was perfect, right? It is a beautiful, unique tower with all the technology. It is mostly one structure, self-standing, but with those elements which nowadays look a little bit old-fashioned, but are very much appropriate to the material they were used in, which was the wrought iron, right? There was not yet the modern steel, but it's the closest they had. It's not cast iron, it's much more developed material. And that tower has been there for the 133 years, right, which is quite remarkable. To say more, the drawings, again, beautiful. It was not just Michelangelo or whoever you might want to consider, right? That office made a set of handmade drawings. This is from publication you can find online. Precise, with one precision and one level of detail I would like to see with AutoCAD or Rhino or whatever, which you can do, of course. But this tells you that the tools are the tools. The concept of drawing being clear, precise, complete, but also beautiful is something that is in the mind and the ability. And I insist, this is an engineer's office, right? And if you see the tools they used, it's unbelievable. With those tools, they were able to make those sets, right? I still used those elements for inking. They are a nightmare. You can be extremely precise, but you spend more time in dealing with the ink than really drawing. And I have to say this, they calculated with a slide ruler, right? This is again an invention of the genius of the mathematicians from Scotland, mostly. They didn't have computers. All that complex tower was calculated based on rough calculations and on just paperwork and a little bit more time doing numbers on paper. Furthermore, you can see this is NASA engineers, right, in the 1960s, making the calculations with the same ruler they used in Eiffel's office. This has been used until the 70s, late 70s, when the electronic calculators entered, and then they didn't make sense. But still, having those hand devices allowed people to have a kind of mental vision of the calculations being clear, not clear. You have not only the numbers, but the concept of the calculation you're doing. With the calculating machines and later with computers, you have so many mistakes because we trust the numbers, the software, the data introduction, and we lost that big numbers, that kind of concept of the calculation. So you have huge mistakes without even realizing. So I wish, again, this goes maybe more to the engineers, but that happens in all orders of life, right? To make the precise calculation by computer, by calculating machine, by whatever, but have a rough idea of the big numbers to see if there's anything which does not fit. There's the construction. Again, when we have the arc, things are stable, but have a slanted tower in construction is a challenge even today. And the achievements, again, this is a great example. It was the first one. There was not any experience. There was not case studies. There was nothing. They were very good at making bridges, but nobody made this tower. So this first, it was a success. It was finished on time, on budget, to the extent that Eiffel himself put his money, he invested his money because he was confident there would be no problem. We will do that with new technologies. Who would say that buildings with all the technological support as say, well, we saw DTP before. Still, we are not clear how much money it costed. And of course, it was delayed for many reasons, right? So this is 19th century, right? And there was 0 casualties. In this time, in bridges, in high rise, that happens in the American Chicago school, New York school. And you know, it happens in Korea, there's many casualties in construction. We had a very sad example recently, right? In a very well-known and very routinary construction, we had quite a lot of casualties in Gwangju. It's very sad. Maybe we comment that in the structure. But this has been the first 0 casualties. And of course, it has been a world icon for Paris, and everybody knows it. How can it be more successful? And this is the great, well, probably the greatest example of the success of good architects and good engineers. Each being clear and knowing very well the role of the other. The architects respectful and very clear, very understanding very well the physical principles of the engineer and the properties of the materials they had. And the engineer being very honest and very clear to the architects to reach this kind of result. Because there are more, we have Maillard, is again one of the Swiss engineer. Those are the guys who created the physics, the formulas we use now, right? And this is the concrete buildings. Well, it's beautiful in itself. Another case from Spain, Torroja is the architect, sorry, the engineer, Eduardo Torroja. Domínguez, no, it's Domínguez, right? The architect. This is much smaller, this is 1936. We are already in less than 100 years ago. This is a thin shell with very thin support. So how can you make this cantilever, right? And that's very ingenious solution with the physics. So this is the cantilever, this is a tiny column, but this is just the counterweight of the canopy to the people below, right? This is the gambling area. Just using the logic, right, can make really amazing works with very, very simple and very safe technology. Let's go back to Nervi and Ponti we saw before. And the Pirelli Tower is one of the most beautiful towers. Well, you may like it or not. The term of beautiful is really telling good architecture, right? We can go into the statics of liking or not liking. This is not the point. Independently of the like or not like, which is personal and subjective, there's objective quality in objects. And we should be aware of that. And this building is very high in that standard. 1958, the same year as the Seagram Tower in New York by, not secret, Seagram, the famous tower by Mies van der Rohe. There was the same year, less famous, was later of some building in Paris by Jean Prouvé, and some others, right? And those guys were inventing the curtain wall at that time. There was not clearly standard. And they create not only a beautiful building, but one of the curtain wall systems that simplified we use nowadays. This is 1958, and you can see this is very similar of that simple but elegant curtain wall we saw in Yoido, right? In the Hyatt Hotel in Yoido. When things are so successful, it's because they are very good from the beginning. And this is, again, a great collaboration, architect-engineer. If we go to the structure, this section tells all, right? You don't need anybody to explain. It is hidden. It doesn't happen as in Eiffel Tower, but you can understand perfectly the logic of those concrete elements going top to bottom, right? And I had to show this. There's nothing to do, but Chio Ponti made one of the most beautiful coffee espresso machines in 1947, much earlier than the tower. And this is what I was telling. Of course, it is not only Chio Ponti. There should be the engineers, right? Because espresso coffee machines are not too difficult, but they're not easy. So how can you make a machine which is beautiful, easy to use, inspiring, and still useful, right? It works. And this is a great example. I cannot stop respecting this generation who were able to do anything just by knowing very well the nature of things, yeah, why they are, why they exist, how they work, and how people use them. So as a conclusion of this, I took one image of Le Corbusier. He liked very much to make short sentences with drawings which symbolize that thing. And Le Corbusier was one of the defenders of the great collaboration of architects and engineers, right? With Le Corbusier, we get only his name, but all his works would have been impossible with in the first period with his cousin, Pierre Jeanneret, but later, and the period with the top-class engineers who were able to make those buildings last. And this is his symbol, right? Two hands crisscrossed, creating something which in the end is very hard to distinguish which is which, right? Well, the image is taken from the poem to the right angle, and you have the reference to it. So what is the problem? That collaboration is so great, and we speak only on one architect, one engineer, right? Or in the case of Eiffel, one engineer, two architects. And it was enough to make those things. What happens today? Well, we became in a society where architecture became a commodity, something which has to be produced cheap, fast, easy, to maximize profits, right? So now the quality of the final product is not the objective at all. It was not the case of those buildings. And I'm sure Pirelli building had a profit, right? But there was an intention to make something unique, special, great, beautiful, everlasting, which is not the case always today. And then we have one system, and I will speak only on Korea, right? Because it's very extreme, in which the whole process of architecture is standardized to have a highest efficiency as possible for cheap and fast. And we have a very weird set of agents. Usually the builder is one of the most powerful, because in large projects, who they are, it's usually the Hyundai Console, Hyundai Construction, or Samsung Engineering. Who is bigger than Hyundai or Samsung? Not even the Korean government, possibly, right? So the owner, if they're not the same corporations, usually the client is something smaller, right? And the construction company, that happens often. And then to be on the level, we have the big architectural office. Big means in the hundreds, right? And we have quite a few ones in Korea, and they work very well in the system. But how those offices work? They just break the project in bits, and they have just the idea, say the concept. And if it is foreign, maybe that trend is not so strong today, but they will hire somebody to make the illustration, the outside. Say, oh, this is designed by whoever from Germany or from whatever. It's a nice design, full stop, which is kind of nonsense if you know what architecture is about. Then you have the schematic design, which often is done in office, but if it is very complicated, it is subcontracted to smaller offices who work on that. Then structural engineers, which maybe are several, because depending on the complexity, you will have specialties and you will break. The systems, of course, you will have different for plumbing, air conditioned, safety, sustainability, whatever. It's all a set of people. Then, well, sorry, the environmental consultants, which part of this could be including landscape architects and all that. You have the facade designers, which is a specialty which appeared, I think, like 10, 15 years ago, when one of the city majors said, oh, apartments are just industrial, they have to be designed. And this is the danger of the word design. That means making them a nice face, which architecture is more than the face, same as people, right? But we have this specialty, and some, and actually good professionals just make just dress the buildings. And the interior designers, of course, which are taking the job from many architects, or in which many architects find a job, because it's very hard to deal with those companies. And landscape designers, which go into it. And this breaking the design in very small bits makes the work very fast, very efficient. Think that those can be also subdivided, but they are a nightmare of coordination. Some people call, some famous architects here in Korea call these architects like design brokers. They hire some people to make the illustration, to win the competition. Then they get a commission from the client, and then they just break the design to bits. They contract as cheap as possible. They give very tight schedules, and they get things back. They put things together, and they just build. That coordination is a nightmare. And this is where the building systems integration comes into play. How can we make those things work together? It's not easy. It's not easy. And this is one of the things we are going to see in our later lectures. But one thing to make easy is those guys in the big offices, if they know the basics of each of the parts, and the same as we commented with those calculations, even if they're not perfectly experts at everything. They have a rough idea on how things work. They can just spot inconsistencies. They can help coordinating because they understand everything and they are very well aware of their design, right? So having that basic knowledge is so important. And this is why you have to study hard and not just to get a lot of information in your head and then pass the exams with good grades, to understand things, right? If humans have this kind of anxiety for knowledge, and speaking of knowledge, not information, is because we want to understand how things work and we deal better with everything. And architecture is not different than life in general. You have to finish, so let me. So again, criteria is minimum cost, known procedures. So this hinders a lot of innovation, you said, or creativity. You just do as always because you don't want to have problems. And I didn't write it, but it's maximum profit. It is greed, pure greed. And this is why integration comes into play, right? We will see, again, ignore the numbers. I thought I have updated, but it's hard to. Okay, this is what we'll see at the end of the semester. So for your own thinking, I used to collect this in written, but I invite you to think. Sometimes thinking is not bad a thing. So what was the architect-engineer relation in today's Korea with the last century, means the 1900s? Or you can go to early classical Korea. We spoke of the Gothic in Europe. At that time, we had the late Koryo, early Joseon. You can go to, even earlier, you can go to Baekje, which was one of the peaks of technology in Korea, and compare with today, right? What is different? And what we have won, what we have lost. So that Korean system, we describe it. What are the advantages? What could we improve? Think that those are just trends. And the trends are based on the general belief. Beliefs are things you just take for granted or you believe, but those beliefs change. And improving things is the task of your generation. Yeah, you are young, energetic, and I guess you want to make a better world, right? To do things to make your contribution. And you start by understanding how things are and how can be improved. We don't need to make revolutions all the time, but we can improve by our own better knowledge and by helping people to know better also things. And finally, this is a bit tricky, but now that you're finishing your studies, you could question, I should question things. The education you get, right, and the building industry on the other side. This is easier because you know it. Building industry, we know from the outside, but it isn't the right track to make Korea again an architectural leader. Maybe construction is getting to the level, right? You have international difficult constructions made by Korean companies, but in terms of design, it's always lagging. What happens there, right? Why cannot we go back to those glories of, especially Baekje, but those classical periods? It is the same Korea. It is a cultural tradition. What changed? What is lost? What can be recovered? Just think about it. You don't have any requirement to submit anything, but I would be happy to see or to hear any of your comments by email or whatever, so I can comment in the following class. So we are 5 minutes to the end, but you need some time to the final survey. The final survey is not yet open. This is the photo of the classroom. We'll have, hopefully from next week, if there's not any disaster happening in between. So I will open now, but before I open it, you will have 5 minutes to start it, right? You have time to call your friends if they're sleeping, because this will give, usually when we do online, the survey or the test one gives 1/3 of attendance and the second gives 2/3. Because I think reaching the end of the lecture has much more merit than being at the beginning in general, right? This one system we used in the last year and kind of worked. So now, as you see the image of the classroom, right? Maybe some of you already studied here, did here architectural materials. while you're aware of what is this, I will open the survey so you can do it, because it has not keywords. Okay, you should be able to see it now, right? 1-2B. Now I think the name is correct. So that's all. I will let you to in the survey. If you have any kind of comment or question, you can write in the chat or email me whenever. That said, I will stop recording, and I will just be here until the hour to see if there's any kind of issue. But otherwise, you can just leave when you finish. You can do it in couple of minutes. You don't need to spend the 5 minutes, right? And as yesterday, if you want to say goodbye, give some comment, you're very welcome. See you Thursday in class. Goodbye.